All right, moving on with the 2016 AP Statistics Free Response section. Starting on number 3, Alzheimer's disease results in a loss of cognitive ability beyond what is expected with typical aging. A local newspaper published an article with the following headline: Study finds strong association between smoking and Alzheimer's. The article reported a study tracked the medical histories of 21,123 men and women for 23 years. The article stated that for those who smoked at least 2 packs of cigarettes a day, the risk of developing Alzheimer's was 2.57 times the risk of those who did not smoke. This should be rather easy. What explains what? In this case, it kind of seems like they're trying to imply that the amount of smoking that somebody does is going to influence the rate that they get Alzheimer's at. So explanatory variable, smoking, specifically 2 or more packs a day versus not smoking, or actually just not smoking 2.5 packs, I suppose. Response variable, developing Alzheimer's. Is the study described in the article an observational study or experiment? This should also be fairly obvious. It's an observational study. First of all, it would be highly unethical for them to actually carry out an experiment and actually force people to smoke 2 packs of cigarettes a day for 23 years. There's serious health implications there. Also, they were just observing them. They weren't imposing that treatment. Furthermore, there was no control. So I kind of ran out of room where I wanted to write that. But when it says explain, you might want to say that this was not an imposed treatment. It was unethical, and there was no control or blinding. Anyways, exercise status, regular weekly exercise versus no regular weekly exercise was mentioned in the article as a possible confounding variable. Explain how exercise status could be a confounding variable in the study. Well, confounding variables are just variables that affect the explanatory and response. One of the explanations that I gave a couple chapters ago was ice cream sales versus shark attacks had a positive correlation, and I can show the amount of shark attacks that happen could correlate really well with ice cream sales. As one increases, so does the other. But that's actually because there's a confounding variable, which would be the weather. When the weather's really hot, shark attacks go up. When the weather's really warm, ice cream sales are also up. Likewise, in the middle of winter, you're not going to see as much ice cream or shark attacks. The weather is a confounding variable. In this case, exercise is a confounding variable because you would think that people who smoke 2 packs of cigarettes probably aren't going to regularly exercise either. So that being cited, they probably don't get regular exercise, and you can't tell the difference in this, whether that Alzheimer's was caused by the smoking or the lack of exercise. You can't differentiate the difference between the 2 variables. See here, fix that. Oh, that makes sense. All right, That's confounding variables. Number 4, go ahead, pause so you can read it. In a couple seconds, I'm going to start it. So some things that are important to know here, the probability of failing to launch is 15. So that means the probability, so actually launching is 1 minus 0.15 or 0.85. So read carefully. Step 2 is repeated until the process stops. So until the superigniter does not work or 32 superigniters have been tested. If the failure rate of the superigniters is 15%, and that's a hypothetical, if it's 15%, what's the probability that the first 30 superigniters selected using the testing process successfully launch rockets? Well, it says they're independent. So the first one of the probability of the first one successfully launching would be 85. Same with the second, same with the third, fourth, fifth, sixth, seventh, all the way up to 30 because they're independent. So that'd just be probability of 1, 30 trials, and that would be 0, 0, about 7, 6, or less than 1%. B, this is a little bit confusing because it makes it sound like it's going to be a conditional probability, I think. But it says, given that the first 30 superigniters successfully launched rockets already, that's already happened. What is the probability that the first failure occurs on the 31st or 32nd? Well, think about if the first 30 have already launched, what's the probability of it failing on that 31st exactly? Since the first 30 have already taken off, this one's independent, it's still just 15. Now, the probability on the 32nd, given that the first 30 have already taken off, for it to fail on the 32nd means it would have had to pass the 31st. Or by past, it would have launched the 31st rocket, but failed on the 32nd. So these two probabilities you can calculate, and it's an or statement. Or statement tells me to add. Quick calculation should be just under 28%. Given that the first 30 superigniters successfully launched rockets, is it reasonable to believe that the failure rate of the superigniters is less than 15%? I don't have to do any terms and conditions because this isn't a formal hypothesis test, but it works like a hypothesis test. So that, I mean, hypothetically, if the proportion was 15 and you're testing less than 15% of the failure. But if we're thinking about this, the first 30 already have taken off. The first 30 trials all launched. We thought that was that. The first 30 launched, and that's very not probable. The first 30 launching is not very probable if the true proportion is 15%. So when we see this 0.007, that's less than 1%, if the true probability of failure was 15%, then this happened less than 1% of the time, which makes me think we should be rejecting the null hypothesis and saying that assuming the failure rate is 0.15, then the probability of 30 successes is only that. So we think the probability actually has decreased less than 15%.